So welcome back to our channel. We're going to be continuing on in inequalities, and what are we doing today? So we are going to be talking about inequalities and learning about or discovering, reinforcing the idea that you learned maybe last year or the year before about inequalities. Okay, there is one difference when you're solving an inequality and an equation. And so hopefully this exploration is going to help you figure it out. So we already did this part up here about adding a number and subtracting a number. Here we said that the one that's bigger stays bigger. The one that stays bigger stays bigger. Okay. If you add Miss Johnson, yeah, it stays bigger. If you subtract Miss Johnson, yeah, it stays bigger. But what if there's negatives? Yeah, it stays bigger. Okay. So now we're going to talk about this one when we multiply. When we multiply, hint, hint, nudge, nudge, wink, wink, right? So I told you guys to make sure you're checking all the different cases. Anybody remember what numbers are special cases? Remember when we talked about this one here? What were our special cases that we talked about? What were some of our special cases? Numbers like what? Very good. 0 was a huge special case. Very good, right? So you want to check 0. Okay, you want to check 0. Check 0 here, check 0 here. See if it's still true what you put. Because we are already asked, right? Which one is going to be bigger? If 5 is bigger than 4, which is greater, 5x or 4x? Or 5 over x or 4 over x? Okay. So check 0. That's my big question. Check your 0. Check your, oh, dun, dun, dun. One of you figured it out. Yeah. Because 0 times anything is going to be 0. Dun, dun, dun. So now does that change your answer of 5x being bigger? Dun, 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 dun. I know you guys like my soundtrack for Miss Johnson's class. Okay. So initially most of you said 5x because 5 is bigger than 4. And I get that. Like you guys probably used a couple numbers, right? You probably used, I don't know, maybe use the number 2. And you said 5 times 2 is 10. 4 times 2 is 8. Look, Miss Johnson, it's still greater than. It is still greater than. So see, it works. Sorry, this was times 2. I don't know why. There you go. Is that better? So, so a lot of you thought initially that 5x is greater. Then you tried 0. Dun, dun, dun. So you went 5 times 0, 4 times 0, and you got 0, 0. 0 is not 0 is not greater than 0. So when we say, is 0 greater than 0? You students will usually say, no, it's equal to 0. Just answer the question. Is 0 greater than 0? The answer is no. Okay. So therefore, we found a case where it, what? Depends. So here, I'm going to copy this up here. And so this is another case, it depends. Back up here. What was another set of numbers that's good to try? What's another set of numbers that we should definitely try here? Besides 0, what other number did we try? Come on, y'all. It's right here. You guys are the ones who told me. Negatives. Good. Someone give me a negative number. So this is equal to, someone said -2. I'm going to go with -2. 5 times -2. Can you beat me to this? Because my computer slash syncing to the iPad you are going to go faster than it. So you tell me, does it hold true with negative numbers? Does it hold true with negative numbers? Answer? Nope, it does not. Very good. In case you forgot, a positive times a negative is a negative. And which one is greater, -8 or -10? So for those of you who don't remember, number one, you can graph these on a number line. I like pictures, so I'm going to go with a number line. So when I draw my number line, here's 0, here's -8, here's -10. Okay. So see how, well, hold on a second. Let me let it catch up to me. There it is. So do you see how -8 is greater than to the right of -10? Everyone okay with that? So then this is the way it goes. But then you should pay attention to this symbol here versus the original symbol they gave us. What happened to this symbol? Literally, this could be the question. This could be the question. What happened to my symbol? What happened to my symbol? I need lots of people to say it, not one person. Like, you should write this down. If we were in physical class, you all would be saying it out loud. It'd be like so loud that the people next door would be like, shut up, right? That's how loud I need it to be. Very good. So some of you said it flipped. Some of you said that it backflipped. Some of you said it switched. Some of you said whatever you said. But you're right. Wait, when did it do that? When did it flip? Can you write that in a complete sentence? When did it flip? So let me write some sentences down as well. Let me see. I want you to fill in this sentence. The symbol changed when we blink by a blink. Yeah, not just multiplied, because look, it didn't change over here. Don't give me just multiplied. So yes, the answer right here is going to be multiplied. I'll make this capitalized. Multiplied. When we multiplied by a what? When did it change? When we multiplied by a what? Be specific. I couldn't even say that word right now. Be specific. Hold on a second. Let me write all this down. Yeah, the symbol changed when we multiplied by a what? By a negative. When we change, it changed when we multiplied by a negative. Because over here, did it change? No, because we didn't multiply by a negative. We multiplied by a positive. Oh, that's right. That makes sense, doesn't it? All right. Try this one. Check the same set of numbers. So here what you're doing, we say that 5 is greater than 4, right? Right. Try using the same kind of numbers and see if we get any changes. Here we never got any changes. If we added a number, if we added a fraction, if we added 0, we didn't get symbol changes. Whoosh. Thank you. Thank you. I'm very blessed. Thank you. My face explodes every now and then. I'm not allergic to math, y'all. I'm not. All right. Did you try some numbers? I'm asking you, when is it going to change? When? When is it going to change? Because if you can figure out when it changes, then over here in homework land, this is homework land over here. When I give you a problem, like, I don't know, this one, you can be like, psh, this one's not going to change. And you should know this already, right? Do you think the symbol here is going to change? Right here. Is this symbol going to change? Everyone's going to be like, no, Miss Johnson. How come? Well, over here, when we added, that's not over here. Let me try again. Over, so anticlimactic when my mouse doesn't work. There. Over here, nothing happened to my symbol. It stayed the same. Greater than, greater than, greater than, greater than, greater than. Always greater than. Whether we added a positive number, a negative number, or 0, right? Stayed the same. All right. So did you try it? Yes. When you multiply, that is true. When I multiply a negative times a negative, it is positive. Correct. All right, let's try this one. So 5 is greater than 4. Which is greater? Now, if you divide, I'm going to use the number 1. You should know why I'm going to use the number 1. I'm going to use the number 1 so my brain can think about it. When I divide, when I divide 5 by 1 and 4 by 1, did the symbol change? 5 divided by 1, 4 divided by 1, did the symbol change? Did the symbol change? No. Dang. Okay. I'm not going to divide by 0. The reason why I'm not going to divide by 0, I don't know if you guys have ever done this. I think I told you to do this. I'm not sure if anybody did. But if you ask Siri to divide by 0, it should give you an answer like this. You can't divide by 0, right? I'll explain it to you. So, like, if you think about dividing, it just means like how many do you get, right? Actually, it's not a symbol of nothing because 0 is a symbol of nothing, right? Or you're saying 0 is a symbol of nothing, yeah. So when I say 10 divided by 2, 10 divided by 2 means this, right? 10 divided by 2 means this. I have $10 and I'm sharing it between me and you. How much do each of us get? $5, right? 10 divided by 0 means this. I have $10. I'm sharing it with 0 people. How much do each wait, what? There's no people to ask. So that's why it doesn't make sense. Okay. All right, so I'm going to move on away from that. You will learn more about this guy in integrated 3, I believe. Dude, I need you over here. Okay. So I'm not going to divide by 0. I am going to try to divide by a negative number. 5 divided by negative 1, 4 divided by negative 1. So first of all, what's 5 divided by negative 1? Yeah, that's very true. What's 5? Yes, it's negative 5. For those of you who don't know, if you divide a positive by a negative, it's negative. Positive divided by negative is a negative. Okay. 4 divided by negative 1 is negative 4. Which one's bigger? Which one's more to the right on a number line? On a number line. Yeah. Miss Johnson, it switched again. Miss Johnson, it switched again. Okay, your job as a mathematician is to observe when things stay the same and when things change. When things change, you should go like this, like, huh, I wonder if that was a coincidence. Okay. Or if that's a fact. So here, it's a fact. So again, the symbol change. When did the symbol change again? When did the symbol change? I'm going to use the power of copy and paste. It's a pretty powerful tool. The symbol changed again when we what? Yes, but with by a negative. But what did we do? Not multiplied. Yes, when we divided. Divide. Right? Okay, so say this again. When does the symbol change? When we add? No. Shake your faces so I know that you're like with me. What about when I subtract? Ooh. No. When I multiply? Yes. When I divide? Yes. Y'all got some funny faces sometimes. Not funny faces, funny expressions, my bad. You have beautiful faces and funny expressions. Okay. So wait, say it again, Miss Johnson. Adding doesn't change it, subtracting doesn't change it, multiplying does, and dividing does. Got it? Okay. So that's it. Kind of. Kind of. Okay. Okay. Who is greater? Okay, now. Y is less than X. Y is less than X. Which is greater? X minus Y or Y minus X? Dun, dun, dun. You guys are like, what? Put numbers in and it'll make more sense. Can you get some numbers? And then don't just try positive numbers, right? The positive numbers are going to give you one thought. Like if you only checked positive numbers here, you would have thought, yeah, nothing happens, Miss Johnson. What are you talking about? So try your different numbers, positives, negatives, zeros, so on. All right. While you're doing that, what shall I do? I shall wait for you. I'm going to drink water because I keep coughing. Oh no, I have no more water. Boom. All right, you guys ready? Yes, ma'am. Okay, so I'm just going to try numbers, like positive numbers first and see what happens. Okay. Anybody have a feeling? Anybody have a feeling which one's bigger? Anybody have a feeling which one's bigger? Which one's bigger? Well, no, which one? X minus Y or Y minus X? Okay, very good. Here we go. So I'm going to pretend, I don't know, 2, oops, I need a pen. 2 is less than 10. Okay, so I'm pretending I'm using 2 is less than 10. So I'm going to check 10 minus 2, 10 minus 2, or 2 minus 10. Got it? So in this case, 8 is greater than negative 8. Dun, dun, dun. I got to switch. I got a symbol switch, Miss Johnson. I got a symbol switch, Miss Johnson. But Miss Johnson, you told me that the switching doesn't happen when we add or subtract. But look, we're not adding and subtracting the same numbers, right? All right, I'm going to use different numbers. I'm going to use negatives. I'm going to go negative 5 is less than 10. Negative 5 is less than 10. So, oops, I should change colors. So negative 5 is less than 10. So I got to go 10 minus negative 5 versus negative 5 minus 10. Can someone help me really quick? What's 10 minus negative 5? What's 10 take away negative 5? Mm-mm. No. Yeah, it's 15. In case you forgot, 10 take away negative 5 works like this, right? So on a number line, if you want to do a number line, you start at 10 and then it says take away mean goes to the left, but then of negative 5 means to go jump this way. So it's positive 15. Another way to think of 10 minus negative 5 is I think about, let me use a different number, 1 minus 7. When I think about subtraction, I really think about adding the opposite. Adding the opposite. So when I add negative 7 to 1, my answer becomes negative. How much negative? 6. Okay. So same thing goes down here. I'm going to add the positive. If you don't believe me, use your friend the calculator. It will tell you that 10 take away negative 5 is positive 15. Uh-oh. You might want to go back and come back in, hun, because can everybody else see my screen? Yes, everybody else can see my screen, hun. Okay, so go out and come back in. But what about this one? What's negative 5 minus 10? Yeah, this is negative 15. Very good. So notice it stayed switched. It stayed switched, right? Interesting? Maybe, maybe not. Okay, the last one I think I want to try is both of them being negative. So I'm going to try the numbers, I don't know, negative 15 is less than negative 10. Negative 15 is less than negative 10. So I'm going to go with negative 10 minus negative 15 and negative 15 minus negative 10. Right? So here I get adding the opposite would give me 5. And then adding the opposite would be negative 5. So all three of them switch. All three of them switch. Does that make sense? So which one is greater? Which one do you want me to highlight? Because I didn't find any cases that I would write depends. Does that make sense? I didn't find any cases and found it depends. So what do I write? Which one is greater, x minus y or y minus x? Yeah, very good. X minus y is bigger. X minus y is bigger in this case. We tested several of them and we came up with x minus y. Okay. So this one here, which one's greater, 5 or x? So now they want you to start solving this equation. Oh, wait, what happened? What?
Because you confused me because in the beginning I wasn't exactly here. So you started talking about the signs flipping.
Symbols.
Like I know the multiplication and the division of a negative, that's when it flips. There's no multiplication or...
Yeah, there actually is. Because this y over here, this y is positive, and this is the opposite of it, right? This x over here is positive, and now it's negative. So technically, there is a little bit of multiplication. We're not going to get into this one too much, but the way you check is you just plug in some numbers and don't plug in the same type of numbers like positive, positive, positive. Notice here I went for positives, negatives, and then a combination of them. If number 6 confused you, that's okay. That's okay. This one's actually a pretty high level one. Come with me to number 7 and let's see if we can figure some stuff out. Okay.
So to solve, well, if we're having trouble solving algebraic equations, especially with variables, we just plug in numbers to like simplify it. Right.
So for this one, yes. But for this one, you already know how to do this. Okay. So here's what I want you to do. For this one right here, I want you to find me x's that work. I want you to find x's that work. Now, before in the land of equation, and I'm literally talking about, 2 lessons ago, right? If I showed you this equation with an equal to sign, so 2x minus 3 equals to 7, all of you know what to do and how to solve this. Okay. So this is very similar to this. So I'm going to use this as my helper. But for now, what I want you to do is I want you to find me x's that work, that make this true. What is the solution to this? Okay. So the very first thing that I want you to do is just pick any number you want, and plug it in to see if it's a solution or not. Okay. So I'll do one with you. Someone give me a number in the chat, please. Someone put 5,000. I'm going to use the number 3 because I don't want to use 5,000 because it's so big. But I will use 5,000, but just give me a second. So I'm going to try the number 3. And when I say I'm going to try the number 3, I'm going to plug it into x. So I'm going to go like this. 2 parentheses 3 minus 3. Are you greater than 7? So do that math with me. What would you do first here, people? Very good. I would multiply. So that's 6 minus 3. Is that greater than 7? Is 3 greater? Oops. Is 3 greater than 7? This is a question. This is a question. Yeah, this is a no. This is a no. So then I'm going to say 3 is not a solution. So over here, I'm going to kind of keep track of our solutions. You guys told me 3, and I'm going to put no. No, you're not a solution. Nope. Does that make sense? So, can you all try a number and find one that you can put here? Yeah, that's the point of it. So, someone asked, can't you just solve this like a linear equation? Exactly. If you get stuck, that's okay. So, find me a number that works or solve this thing as if it's an equation. Not yet. Let's let everybody work. So right now I want everybody either number 1 solving this equation and finding me a number that works or that doesn't work. Just plug in a number. No worries. Someone said I tried 10 and it works, Miss Johnson. Let me just check. 2 times 10 is 20. Minus 3 is bigger than 7. Okay, so over here, maybe over here, someone said oops, they tried, they tried 10, sorry. They tried 10 and it works. Okay. Yeah. You can do this on Desmos for sure. You're supposed to be finding a number that works and trying to solve this equation. You already know how to solve this equation, not trying, solving. Okay, if you're done with this, oh, scary. If you're done with this, try this one. For sure, try this one. Okay, because this one, something happens. Foreshadowing. Ooh. Ah. Okay, so did you choose a number? Give me some numbers that you guys tried and tell me yes or no. Like someone put in the chat, I used number 10 and it worked. That's why I graphed it right here. Someone said 8. Did 8 work? Yeah, 2 people told me 8. Did it work? Someone said 14, it worked. 8 works. Okay, so let me just graph a couple of these. Someone said 8, it worked. Someone said 14, it worked. So here's a little math shortcut. Because 8 works, 10 works, and 14 works, do you think I should just try 12? Or do you guess that it would work? Yeah, 8 worked. Yeah. Because look, 2 times 8 is 16. 16 minus 3 is 13, which is bigger than 7. So it works. Yeah, if you try 12, it's going to work because he's around a bunch of people who work, right? Birds of a feather, they kind of flock together. You guys have heard that, right? Someone said 6. Does 6 work? Did you find out that 6 works or no? Oh, 6 works. Okay. Thanks for telling me that. I'll put 6 over here and they said it works. All right. Now find me some numbers that don't work. Since all of these guys work and 3 didn't work. 2. What would you assume? 2 works or doesn't work? What would you assume about 2? Works or doesn't work? Yeah, 2 doesn't work. Someone said 5. What about 5? Did 5 work? Did 5 work? Yeah, 5 doesn't work either. Huh. So 5 doesn't work and 6 works. I think we got really close to our answer. Okay, so let's pause on that. Can you solve this equation with me? Solve this equation with me. What's the first thing that you would do? Oh, go ahead. Sorry. If you would like to write on my board, write on my board. Go ahead. You guys can all annotate on here.
Okay, so the unit itself, wait, let me open it. Great job. The unit itself is called equations and inequalities. If you think about it, this kind of looks like an equation. Well, no, it is an equation. This also kind of looks like an equation, right? Yeah. So we can solve this by using SADMAP, guys. Because the unit is called equations and inequalities. Why would we have the unit all be in one if they're completely two different topics? So what can we do to oppose this? So that's 3. Wow, that's canceled out. Then we have this, which 7 plus 3, I think we can all do that, right? So 10. And then 2x equals 10. So what times 2 would equal 10? If you divide, you get 5. X equals 5. You can solve this entire thing using a linear equation. And what I find is different, instead of using the equal sign, you just use the greater than or less than sign. Unless it's greater than or equal to, but that's a different scenario.
Okay, so question. Are you all comfortable with adding 5 to both sides? Is that something that you guys are all comfortable with? We can add 3 to both sides. Everyone's good. Nod your head like this. Yes, yes, good. Okay. What about dividing by 2? Everyone's okay with that? All right. Now we're going to change it back to a greater than symbol. So all I'm going to do is I'm just going to make a bigger greater than symbol in highlighter and see if anything happens. You told me earlier that when I add something to both sides, yes, you can leave and come back. To both sides, when I add something to both sides, did the symbol change? When I added something to both sides, very good. No, you should all be shaking your head. No. So now then you know the answer. Listen, when I added 3 to both sides, did the symbol change? Everyone's like, no. So keep the symbol? Yes, keep the symbol. Sorry, I'm just guessing where the greater than symbol is there. And then when I divided by 2, did my symbol change? Up here, when I divided by 2, would my symbol change? Everyone says no. Say it like this, no. Wait, remind me again. When does my symbol change?
When it's negative, when the number we
No. You got to say it like we said it. When we blank or blank by a blank. Say it out loud. When we
multiply/divide by a negative number.
Perfect. When we what? This is all of you. I know the answer. You all need to say this. In fact, if we were in class, by the end of today, we probably would have said it like 15 times. So when you what or what by a what, we do what? When we multiply, good, or divide, good, by a what? By a what? A negative, right? What do we do? What do we have to do? Flip your symbol, right? We flip our symbol. So our symbol didn't flip here, Miss Johnson. That's right. Because we didn't multiply or divide by a negative. But Miss Johnson, we multiplied. Yeah, but we didn't divide by a negative, or we divided, right? So then I'm going to solve this equation right here. I'm just going to take this and move it over just so we have more room. I am now going to solve this inequality, and then you're going to compare it to this. And you're going to you're going to decide if that's true. Okay? If it's really true what she said. She said that it's really just like solving equations. All right. So how do we inverse -3? Everyone says. Oh, you're going to add 3, Miss Johnson. All right. Oops, I'm in pencil mode. My bad. So I'm going to add 3 to both sides. And if you're wondering why did I add 3 first, because of SADMEP, we have to take care of subtraction and addition first. You are. But I can't see your name. All right. So then I'm going to have 2x, and then I put 10. And then I ask myself the $1,000,000 question. Do I switch my symbol? Which one? No. Everyone says no. Good. Why not? And you're like, oh my gosh, Miss Johnson, because we didn't multiply or divide by negative. Yes. Right? We didn't multiply or divide by a negative, Miss Johnson. Okay. Okay, then I say, okay, fine. How do you undo multiplying by 2? You guys say what? How do I undo multiplying by 2? Very good. Divide by what? Divide by what? What am I dividing by? 2. And all your brain should be like, oh my gosh, is this the moment that we're going to switch our symbol? Okay, and then we say, okay, well, that's x, that's 5, right? And then I ask, do we switch our symbol? Do we switch our symbol? My nails are being bitten. Just kidding. Do we switch our symbol? Everyone says no, Miss Johnson, because we didn't multiply or divide by a negative number. Oh, okay. So then I just need to teach you. Okay, any questions on this before I move on? Any questions on this? So we already knew what we already knew this? Yes. So the only thing that we learned was this up here. If we multiply or divide by a negative, then we switch our symbol? Yes. Okay. Okay, here we go. Yeah, you can move on to the next one. Perfect. So I just need to now show you how to graph it, and then we're done. So I'm going to take this over here. Do you guys know how to say this in English? Do you know how to say this in English? How do you say this in English? In words?
Greater than 5.
Kind of. But I'm not going to use the. You're not going to let me type. Please let me type. Oh, wait. Yeah, I'm not going to use the number X. I'm not going to use the word X. I want you to say all the numbers. Say all the numbers, and then say the rest of what you said. So all the numbers. Good. If I could type right now, I'd be typing, but I can't for some reason. Draw. Yeah, it's not going to let me type. Look at that. Not letting me type.
Wait, do we say all the numbers are greater than 5?
No,
Just
all the numbers that are greater than 5. There you go.
okay.
All numbers greater than 5. That's your solution. All the numbers greater than 5. Okay. So don't say X's. And the reason why I don't want you to say X is because then you think like you're not talking about numbers. I'm talking about numbers. So it's all numbers greater than 5. Oh, like 6, Miss Johnson? Yeah. Like 8, Miss Johnson? Yeah. Like 10, Miss Johnson? Yeah. Like 14, Miss Johnson? Yeah. Yeah. Because X is not any number, it's only the numbers that are greater than 5. So the way I write this is like this. This is how I graph all the numbers greater than 5. Ready? Don't blink. For this, I will use my special glittery pen. I know, so fabulous. Blah, 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 blah. This is how I write all the numbers greater than 5. Miss Johnson, but you circled 5. Yeah, right? I did circle 5. Yeah, I circled 5 on purpose. So, Miss Johnson, doesn't it look like the answer is 5? Yeah. If you see this as the answer is 5, that's not what the open circle means. The open circle means all the numbers bigger than 5, not including 5. Not including 5. So if I colored that circle in, like imagine me coloring it in, coloring it in, coloring it in, then that would include 5. So if Miss Johnson, can I do that for 6? No, because then you would be wrong. If you think that the number line should look like this, okay, you're wrong. What numbers did you not include? What numbers did you not include? What numbers did I include here, but not here? Oh, okay. So I can color in 6. No problem. No problem. I forgot a big set of numbers. Where are the numbers? Think decimal. Think decimal. Not 1.3. 1.3 is definitely, it's over here. It's not a solution. Yeah, the in-betweeners. So all the numbers between 5 and 6 are solutions. Like what? Like 5.2. 5.2 is a solution. But here, you didn't include it. But see here, I included it. Got it? So that's why we open circle and go to the right, because it's all the numbers to the right of 5, not including 5. Okay. All right, right now, you are going to use this. You're going to solve it. Oh, we didn't even answer this. Which is greater, 5 or x? Look at this picture. Which is greater, 5 or x? Answer. Which is greater? Yeah, very good. Good job. X is bigger. Very, very strong work. How could you tell? Because these are all the numbers, and it says all the numbers bigger than 5. Okay, so your job, you are going to try this one right now. By the way, if you notice, these steps are exactly the same, just the symbols. So in reality, you need to find all the times that you're multiplying or dividing by a because then you have to Okay. So I'm going to pause it really quick. You guys are going to try this one right here. If you're done, then try this one right here. And then I'm pretty much done. So right now, I need you to try number 8 and number 9. We're going to come back and do number 8 together. All right. So I'm going to walk through this slowly because I don't see a lot of people like, boom, I get it. And that's okay. So I start with SADMAP and I say, hey, do you see any subtraction or addition on this side? And you guys all say, yeah, I see subtraction. But technically, for the 10, it's being added because that 10 is positive, right? So how do you get rid of a plus 10? You guys all say what? Yeah, subtract 10. So if I subtract on both sides, do I flip my symbol? Do I flip my symbol? You guys all say what? Wait, when do you flip the symbol again? Please type that out. When do you flip your symbol again? When you blank or blank by a blank? When you blank or blank by a blank. I flip my symbol when you blank or blank by blank. So some people are saying when it's negative. Miss Johnson, that's a negative. Flip the symbol. You didn't memorize the whole rule. It's when you multiply or divide by. Am I multiplying or dividing? Everyone says no. So do we flip it? No. So keep my symbol? Yes. All right, 6 minus 10, I will tell you, is negative 4. If you don't know, be comfortable with using a calculator. Okay. This is where some of you got it wrong. Okay. So negative 2x. This is a negative 2x. The negative doesn't float away and go away. It's a negative 2x, right? Okay. No, you can't multiply 2x times 6. I mean, you can, but it doesn't get you closer to the answer. All right, what do we do next? All right, so I'm done with subtraction and addition. Done. Is there any division or multiplication? Everyone's like, yes. Good. Divide by what? Divide by what? Very good. Negative 2. The alarms should be going off in your head. Why are the alarms going off in your head? Why? I know. Scary, right? Why are the alarms going off in your head? Waiting for the chat is so like, I don't know. Maybe it's because I need to work on my patience. Yes, we have to flip the symbol. Why do we have to flip the symbol? Why do we have to flip the symbol? I don't know why, but I'm looking at Nayeli's cat in the window. It's very fascinating, y'all. Shoot. Sorry. Yes, because we divided by a negative. Muy bien. Okay, so I flip my symbol. Do you guys know what negative 4 divided by negative 2 is? Do you know what negative 4 divided by negative 2 is?
Positive 2, but then negative divided by negative.
Another way to check is because 2 times negative 2 is negative 4. Because 2 times negative 2 is negative 4. Very good. So I switch my symbol, Miss Johnson. I switch my symbol. Then we graph it. We graph 2. Should I open the circle or should I color the circle in? Open, closed, open, closed, open, 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 closed. Which one? Yes, very good. It's open and it's to the right. Very good. This is what it means. It means all the numbers bigger than 2. All the numbers bigger than 2. Okay. Last question. How would you check your answer, Miss Johnson? Check any of these numbers that are colored in and it should work. Like, remember how one of your classmates said like 5,000? Sure. Check 5,000. So let's do that together. 10 minus 2 times 5,000. So 2 times 5,000 is 10,000. 10 minus 10,000 is a really negative number. That negative number is definitely smaller than 6. So, yes, sir, 5,000 is an answer. Does that make sense? Okay. All right, I'm going to stop the video. Okay, so this is what you're going to do. This is the question for today. Ready? This is the question for today. Ready? When do you flip your symbol? Please do not answer me in a short sentence. You are like my adults. You are going to answer in a complete sentence. The sentence should look like this. I flip my symbol, blah, blah, blah. Good? All right, very good. If you know the answer, awesome. If you need to look back at notes, awesome.